Good morning, students. In a previous class, I have explained Newton's first law and second law. Today, I am going to explain Newton's third law of motion, which is very important. What is Newton's third law of motion? For every action, there is an equal and opposite reaction, and action equal to minus reaction. Minus means opposite. So every action has an equal and opposite reaction. And some more examples I'm going to introduce. Motion of rocket. When fuel is burned, the pressure inside the chamber rises very high. Due to high pressure inside, the hot gases are coming out, and consequently the rocket rushes in the opposite direction of gases. And finally, the motion of a rocket can be explained on the basis of Newton's third law of motion. So, whenever gases are coming out, action, and rocket is moving up, reaction. In the process of walking, pushing earth with our feet is a part of action, and consequently, the earth pushes against the feet. It is the reaction. So here action equal to minus reaction. This is the Newton's third law. When a gun is fired, it exerts a forward force on the bullet. The bullet exerts an equal and opposite force on the gun. This results in the recoil of the gun. So, a forward force on the bullet and recoil of the gun is the best example of Newton's third law. It is the best application of Newton's third law. Action equal to minus reaction. And last example. As the man jumps in forward direction, the boat moves backward direction. Here action, reaction. So this is the best example of Newton's third laws. For every action there is an equal and opposite reaction. Action equal to minus reaction. So in the part of Newton's third law, we are going to explain conservation of momentum. What is conservation of momentum? Total momentum before collision equal to total momentum after collision. And the equation m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. Before going to prove this one, we are going to once again explain momentum. Momentum means mathematical definition, the product of mass and velocity, p equal to mv. I am going to prove the law of conservation of momentum. What is law of conservation of momentum? Total momentum before collision equal to total momentum after collision. I am going to explain once again what is law of conservation of momentum. Total momentum before collision equal to total momentum after collision. Now I am going to prove the law of conservation of momentum. So I have taken activity. I have taken two objects. Those are A and B. A is having m1 mass and B is having m2 mass. Before collision, A mass having u1 velocity and B mass of the object having u2 velocity. After collision, what happens? Their velocity changes. The spherical object of A having the velocity v1 and B objects gets the velocity v2. Now calculate initial momentum of A spherical objects. So momentum formula, mass and velocity, product of mass and velocity. So m1 u1 B. Initial momentum m2 u2. So A, after collision, the momentum is for A object m1 v1, for B object m2 v2. So what the law of conservation of momentum explains? Total momentum before collision, that's why I am using a plus, is equal to total momentum after collision. So total momentum before collision equal to total momentum after collision, and the equation m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. During collision, the force A exerted on B, simultaneously the force exerted B on A. So here you can apply Newton's third law. What is Newton's third law? Action equal to minus reaction. Action equal to minus reaction. What is action? Action means the force exerted from A to B reaction by resultant B exerted force on A. So B to A. So the force A is main criteria. Your force B, mass of the spherical object. That is the main criteria. Going to calculate the force which is applied by A mass of the spherical objects. Before going to calculate force formula you know that F equal to ma. Acceleration formula v minus u by t. V minus u by t. Therefore F equal to. So I am going to calculate A spherical objects. A mass is what? m1. For A, final speed is or final velocity is v1 minus A object initial velocity is u1 by time t1. Going to apply the B spherical ball exertion force on A. Generally, before calculating force formula F equal to ma, F equal to m. A means acceleration formula v minus u by t. Apply for B spherical, m2 mass of the object, B mass is m2. Writing here, B mass is m2 and final speed is v2 minus initial speed is u2 by time t2. The force applied from A to B, from A side, the equation is m1 v1 minus u1 by t1, and B spherical objects m2 into v2 minus u2 by t2. These are two products or two formulas I can substitute from obtaining equation the action equal to minus reaction. Now f of a, what you got it? m1 v1 minus u1 by t1 equal to minus of m2 into v2 minus u2 by t2. Then one thing you have to mind it. A accepted force, the force accepted from A to B and B to A are getting same timings. So that T1 equal to T, T2 equal to T. Now in this equation, T cancel. Now as a part of action equal to minus reaction, what I am getting? The continuation M1 of V1 minus U1 is equal to minus of M2 into V2 minus U2. That implies M1 V1 minus M1 U1 equal to minus of M2 V2 plus M2 U2. That implies M1 V1, whenever it is coming from right hand side to left hand side, plus M2 V2 is equal to, when this product M1 U1 is going from left side LHS to RHS, so plus M1 U1 plus M2 U2. And we all know that A equal to B, automatically B equal to A according to mathematics transistor property. So M1 U1 plus M2 U2 equal to M1 V1 plus M2 V2. So this equation, law of conservation of momentum. So what is the law of conservation of momentum? Total momentum before collision equal to total momentum after collision. So this is the proof of law of conservation of momentum. So another condition I am going to explain. A, m1 mass of the spherical objects collides. B, m2 mass of the spherical objects which is moving. U1 velocity for A and B is U2 velocity. After collision, for example, both are together and moving. Both are combined and moving. So then they will get common velocity. That is V. So what equation you are getting from law of conservation of momentum? M1 U1 plus M2 U2 is equal to M1 V2 plus M1 V1 plus M2 V2. After collision, both are moving together. That's why your V1 equal to V2 equal to V. Now M1 U1 plus M2 U2 equal to M1 V1 equal to V and M2 V2 equal to V. So take common V. That is M1 plus M2. So this is condition. After collision, both are moving together. Then the equation of conservation of momentum m1 u1 plus m2 u2 is equal to v into v is the common velocity v into m1 plus m2. Two masses m1 m2 both are collided each other. After collision, both are stick together and moving. Then the final equation is m1 u1 plus m2 u2 equal to v into m1 plus m2. V is common velocity. Thank you.